Okay, the converse of that is also true. So this is the converse of the perpendicular bisector theorem. And this one says if a point is equidistant, ooh, that is not cute. Try that again. If a point is equidistant, sorry, I don't know what this is doing right now. It doesn't like me very much. If a point is equidistant from the endpoints, then the point is on the perpendicular bisector. So remember, a converse is just rearrange your hypothesis and your conclusion, right? So we just took the if-then portions and we swapped them. That's the converse of that. So same thing. Now we're saying if I know that these two pieces are congruent, for instance, then I know that this point is on the perpendicular bisector of the segment. Okay, the point that's going to cut that segment in half and make it 90 degrees. Questions on that? Okay, so here's what we're going to do. Look at this picture, example 1. Notice what they're telling us. They're telling us this is 90 degrees, and they're telling us these are congruent. Okay, that means that EG is a perpendicular bisector. Okay, and we said if you have a perpendicular bisector, any point on that is the same distance to your endpoints. What are my endpoints right now? Which 2 points would they have to be the same distance to? D and F. Okay, so what that's saying is because of all the orange markings, then I know this must be congruent to that. So how do I solve for X? If those are congruent, what's another word for congruent? Equal. We set them equal, okay? So we're going to take these two pieces of information and set them equal. 2x equals x plus 6. So take away your x, and you get x equals 6. So then how do you find EF? What's the length of EF? EF is this one, right?
12.
It'd be 12, right? It's 2x. So 2 times 6 would give you 12 for EF. Okay, look at letter B there. Letter B says that this is perpendicular and these are congruent. So what is our perpendicular bisector? Which segment or line? Not RT and ST. Those are the ones that'll be equidistant. UT is your perpendicular bisector. So this is perpendicular and it's cutting it in half. That means any point on that orange line is the same distance to R as it is to S. So what do? Yeah, this segment has to be equal to that one. So we're going to say 10x minus 3 equals 5x plus 2. How do you solve that?
Plus 3.
We can add the 3. So we get 10x equals 5x plus 5. Then what?
Remove the 5x.
Take away the 5x. I would have done that first. So if you guys did the 5x first, that's totally fine. That's what I would have done. But it's not wrong to do it this way. So we get 5x equals 5. Divide by 5. So x is 1. So what is RT? How do you find this length? RT. Not double it. We know what x is, right? And we know what it equals with an x. It's 10x minus 3.
It's 7.
So you plug in the 1. Yeah, 10 times 1 minus 3. So 10 minus 3 is 7. So RT is 7.
I think we deserve dance.
Does that make sense?
I think you deserve a little. Dance party break.
You want a dance party break?
Yeah.
Dance away.
Kindergarten. We should dance. I think we should do this exercise called the pumpernickel. From 49.
Questions on that?
No, I'm doing pretty good.
Okay. That's the perpendicular bisector. Okay. What is that called? What's the pumpernickel? I'm good. Oh, I'll ask my kid. Oh, you guys. Speaking of Fortnite, back to it. You had your brain break. So that was perpendicular bisectors, right? Forrest, we're done. Now this is angle bisectors. So similar idea. What does a bisector do? Cuts something in half, okay? So now instead of cutting a segment in half, we're cutting an angle in half, right? Angle bisector. Okay. So there is, again, two theorems, the angle bisector theorem and the converse of the angle bisector theorem. And it says this. If a point is on the bisector of an angle, then the point is equidistant. See how things are equidistant a lot? Max, stop waving and take notes. So if it's on the bisector, okay, look at this picture. Shh. This is an angle bisector, right? AD is an angle bisector because they marked these two angles congruent. Okay? So what they're saying is if a point falls anywhere on AD, so in this case, point D is what they used, it will be the same distance to AB as it is to AC. Okay? So this distance here, and they always make the distance perpendicular. Don't confuse that with a perpendicular bisector. It's just perpendicular. Okay? That distance will be the same as this distance. So this will equal that. Okay? Or I could pick a different point. I could go right here. And as long as I go perpendicular here and perpendicular here, those lengths will be the same. Okay? Or I could go here. And as long as I go perpendicular here and perpendicular here, then those two lengths will be the same. So the distance to the rays of the angle has to be the same. Equidistant, right? The same distance. Quit. See, this is why I can't do brain breaks with you, because you won't come back.
I was just waving.
Yeah, I tried to let you have your little dance moment. It doesn't work. This is my point.
I think we need Wodo to walk back in.
No. Okay, the converse of that says if a point is equidistant from the sides, then it's on the angle bisector. Okay, so now they're saying this. If we know that this point is the same distance here as it is there, then we know that that point is on the bisector. Okay, so it's really the same information, just in a different order is what you're looking at. So let's look at those examples. So this is example 2. It says find the indicated measures. And the indicated measures are these, right? Find BD, find DC, and find the measure of angle CAB. Okay, so look at BD. Okay, BD is this. We want to know how long is that. Does anyone see what you need to do in this problem to be able to find that?
Solve for x.
How?
Set both of the lengths equal.
Set them equal. Because they told us these angles are equal and these are right angles, then we know that these two segments have to be the same. Okay? So we're just going to say 3x plus 1 equals 5x minus 1. So take away the 3x and add the 1 and then divide by 2. So we get x is 1. So what's the length of BD if x is 1?
4.
Right, you're doing 3 times 1 plus 1, which is 4. Okay, so BD has a length of 4. Okay, look at the next one. DC is this length right here. How long is that?
30.
It's not 30. 30 is the angle, right? These are 30-degree angles. So it is 5. What this is telling you, Max, we're not sleeping right now. Sit up. What this is telling you is this is the angle bisector. So the distance to our angles has to be the same. So if this one is 5, then this one has to be 5 also. Okay? Truett, put that away.
What away? Wait, just for one thing. Do you know if Miss Cortez is here today?
I don't know. I know her mom had surgery yesterday. So I guess it depends how things are going with that.
Period. That actually looks like it's
Yo, that looks like the Fast
All right.
and Furious dude. He looks like the Fast and Furious dude.
You mean Vin Diesel?
Yeah, whatever his name is.
Why does that mean?
Because he's just a bald guy. He's a
Bald has
bald
sunglasses on.
bald with the sunglasses on. I was like, it looks like Vin Diesel.
Well, you guys say people look like Cadence's mom all day long.
That's like more ironic.
No, they do.
They don't actually
know
look
what
like
my
Cadence's
mom
mom.
looks like.
Yeah, it's just more make fun of Cadence.
Yes, I have a mom.
Yeah, you guys are rude is the point. Okay, CAB. So look at this picture. Shh, listen. Because they are telling us that these are right angles and these are congruent, we know that AD is an angle bisector. So what is the measure of that orange angle? Max.
How would I use this in life?
You ask this all the time.
This particular thing, you might not use in life.
Maybe go into a doorstop building.
A doorstop building company.
If I got a door, it's gonna be weird. Yeah.
But here's the thing. Even if there's never a use for this particular idea in your particular life, you are learning to be a good problem solver in working through these. You're using to be a critical thinker.
I'm gonna forget this in like a month.
Don't.
I won't forget
That's
this.
just how my brain works. I don't remember what the
Anyway,
first lesson
okay,
is.
so this distance being the same as this distance means that AD is an angle bisector. And if AD is an angle bisector, what is this angle?
20.
20. So the whole orange angle is 20 plus 20, or 40. Okay? Questions on that?
No.
All right, last one. Hey, if you focus for me, I'll let you wordle.
Okay, I'll back off.
Tell me about this problem. What do you know?
It looks like that star.
It looks like a stingray.
What are congruent?
5 and 5.
The 5 and 5, okay, because these are the same length. What does that mean for our angles?
They're congruent.
The angles will be equal because this will be, Apple Pencil's dying. Yeah, equal.
Sick.
These will be congruent because that makes this an angle bisector. You don't add them. If they're congruent, they're equal. So you set them equal. 4x equals 2x plus 20.
So it's 10.
Take away the 2x. So 2x equals 20. And then divide by 2. So x is 10.
That was one of the easier problems. Like that one.
I did that in my head.
You know why it was easy?
Because we're getting better.
Because you were quiet and listening,
Bro,
not
it's like-
screwing around. None of these are difficult today.